we continue the section 4b. Now that we have examples for a right angle n superscript m. Okay, so example. An annuity pays $6,000 per annum in quarterly payments for 7 years. So that means for 7 years, but the payments are quarterly. So we have the 28 payments. And each payment is $1,500. Okay, so suppose that I is equal to 5%. This is annual rate. So determine the present value and accumulated value of the annuity. Yeah, so the situation is this. So we have 7 years. So we have, okay, so just we use the year as the time unit, then 1 quarter and 2 quarters and 3 quarters and so on. 1 and the 1 plus 1 quarter and up to, okay, so 2 and up to 7. And for each quarter, you get the $1,500. So $6,000 per year. Then annual interest rate is 5%. So solution 1, so we use the method for 4b, and solution 2 that we use the method for 4a. So first one, the time unit 1 year. So we use the formula that we discussed in the previous videos. Yeah, so present value is here. So this is the $6,000 payments per year. And the payment is for 7 years, but the paid quarterly. So a right angle 7 superscript 4, and the interest rate is 5%. So this is equal to the 6,000 times the 0.05. This is I, then I superscript 4. And times the a right angle 7 at 0.05. Okay, so now that we want to calculate the I superscript 4. And the 1 plus the I superscript 4 over 4, this is equal to 1 plus 0.05 to the quarter power. So that means the 0.05 to the 4 superscript 4 is equal to 4 times 1.05 to the 4th power minus 1. So this becomes 0.4909. Sorry, the 0.04909. So always this is slightly less than 5% because it compounds the 4 times a year. Yeah, so now that we can calculate this quantity. So this present value is equal to the 0.05 over 0.04909 times the annuity immediate. So annuity immediate. So a right angle 7, 0.05. So this is equal to 5.786. So this becomes, yeah, and sorry, that we have to multiply 6,000. So that this times 6,000. So this becomes $35,363. So now we got the answer. Yeah, so I want to mention that the a right angle n superscript m and a right angle n is small, are close, but it's slightly, this is slightly larger than a right angle n. Since the payments are earlier than. So these are close, but slightly larger, earlier than. Earlier for a right angle and superscript m. So we say this as time value of money. So time is variable for fixed income products. If you receive earlier, basically we can assume the interest on that. Okay, so this is the first method. So basically we use the formula. And the only thing we have to calculate is this, the I superscript 4. And of course, we have to apply the annuity formula once. And another solution, so this is by 4a. So we use the frequency equal to the 1 over quarter year. So the quarterly payment. So 1 over quarter year. So this has the annuity with the 28 quarterly payments of $1,500 each. The quarterly effective interest rate is what? That is 1.05. This is annual rate to the 4th power minus 1. So this is equal to 0.01227. So this is the 1.227%. So the present value is the annuity for 28 payments. So 28 payments at the interest rate of 1.227%. And we have $1,500 payment. So this is equal to 35363. So in a common sense, the solution 2 is much faster than solution 1. So only thing we have to do is to translate everything to quarterly basis. So most of the time that we recommend this method. So payment frequency is equal to the so we use the payment frequency as the time unit. But if we know more formula, sometimes that we can use the time unit is equal to the so time unit is equal to the period for the interest bearing period.